Abu Bakr KM FIC DIC ED Club speaking on the topic Introduction to IoT and Machine Learning. Welcome, sir. We also welcome the enthusiastic participants to our event, hoping the session would bring new insights and knowledge to each of you. Starting off with the event, I invite Diona to welcome our distinguished speaker of the day, Professor Abu Bakr KM.
Mr. Abu Bakr KM has a remarkable experience of over 10 years in the field of electronics and communication. He is specialized in IoT, machine learning, open source hardware and software development, and visual processing. Mr. Abu Bakr has notably authored numerous academic papers and books, some of which are part of the APJ K2 and MG curricula. Today, he is here to take a workshop on the topic Sensor Data Deployment on Cloud with an IoT Framework. We welcome Mr. Abu Bakr to address the gathering and to conduct a much look forward to workshop session. So your mic is mute.
Thank you very much. My dear faculties, students, and their participants, very good afternoon, all of you. Today, we are starting a program for product development week under the guidance of IEDC. For the next 4 days, we will familiarize so many types of industrial development applications in different areas like the robotics, then machine learning, then PCB designing, automobile industries, etc. Today I will present some topics related to the Internet of Things, then how we can deploy the sensor data to the cloud services using some types of hardware development platforms, mostly adaptable for the industries as well as for the students community and research communities. The main topics we are planning to discuss under today's session is, we'll discuss what are the concepts of Internet of Things and their frameworks. And second, we will discuss the different types of IoT development boards and prototyping boards available in our markets for researchers and industrialists. Then we will switch these topics into different cloud platforms available for the IoT and sensor deployment, and which one is most suitable for the different applications, for especially for researchers or industries as well as for the students project. Then in a small hands-on experience, I will show you how to deploy some data from your sensor data, how to upload into the IoT cloud, as well as what are the applications of imaging or how to upload some image or videos to a particular cloud, etc. These are the agendas we are planning to execute under today's sessions. We'll introduce the concept, what about this Internet of Things, or which framework is most suitable for your applications. What do you mean by an IoT? Normally, we have heard that so many examples of the IoT applications of IoT in our real-time applications, because the development of wireless technologies is moving from 4G technologies to 5G technology. We know that during the last 6 or 7 years of experience, you can see that the IoT or connected devices, especially in the field of medical applications or medical sensor deployment. For example, nowadays most of them are familiarized or wearing some types of health bands. It will measure some information or body parameter like the temperature, then how many footsteps are required, what about the heartbeat, even for a non-invasive types sensors are also available for making the glucose level of blood glucose levels, etc. Nowadays, there are two classifications of sensor devices are commonly used in IoT applications. The first type of classification of sensor deployment is whether that device is invasive types or non-invasive types. For example, we are familiarized how to how to measure the blood glucose level of a human body. Nowadays, we are using some invasive types. We have to tap this blood to some sensor devices, or we have to process some mechanical or chemical operations on that. But nowadays, non-invasive types of glucometers or glucose measurement systems are also developed because of the development of IoT as well as the sensor deployment. So nowadays, your invasive type sensor devices are replaced by the non-invasive type of sensors because of the development of 4G technologies. As we are going to enter into these 5G technologies, we have probably know that the data transfer or data width of 4G is maybe 20% is higher than this, less than this 5G technology. It will be 0.2% or 0.2 gigabits per second of information will be downloaded more than compared to this 4G technologies. So the moving of this 5G as well as the wireless technologies and connected devices. So without these wireless technologies, we cannot able to connect the sensor devices to IoT, or we cannot able to deploy some data from the connected or wearable devices to your cloud services, etc. But with the combined operations of the sensor technologies and the wireless technology, we have developing platforms of IoT frameworks. Nowadays, we are having so many types of IoT hardware and software platforms are available as a free. Software platforms are available for research applications and your academic applications. The forthcoming sessions will discuss what are the things related to the IoT or hardware and software requirements of IoT frameworks. These are the main components of your internet topics. We can see that there are 5 different sections are integrated into a common platforms. Without this, for 5 units of information or units of block of information, we cannot able to complete this structure as IoT framework. We know that the first parameter of your IoT framework will be the sensor devices. It may be either non-invasive types or invasive type sensors, or it may be analog types or digital type sensors are there. Then depends upon these microcontroller devices or your hardware deployment platforms, we have to choose what type of sensors are most suitable for your applications. For example, when we are dealing with the digital devices or microcontrollers or microprocessors or GPU units, we know that definitely it will accept only digital information from the outside. Right. Nowadays, most of these analog sensors are replaced by the digital sensors. The advantage of your digital sensor data is we cannot able to perform some operations or conversion operations is may not be required. You can try to read the data from a single line informations. It is a series of data. Most probably it is the data from the sensor unit is sent to this microcontroller board or your IoT platform as a packets of data or data packets. You know that the structure of your data packets will have some meaningful information or sensor data along with some error correction bit, then start bit and stop bits, etc. As compared to your data packets in your local area networks or wide area network, it is also having the same format or structure or frame structure. Similar to that, the data from your digital sensors that can be connected to your microcontroller by using serial communication protocols or a two-wire communications protocol. Then how to after communicating between the sensor devices to your IoT platforms or IoT hardware platform, how it can be uploaded to or deployed to cloud services or some other data storage applications that can be accessible from anywhere in the world. It may be some, there are 2 options are there. Your cloud service can be configured as a private cloud or configured as a public cloud. You know that in private cloud, the recommended users can only accessible this information if it is we are having or it will be a secure information. We should have to create your cloud as a private forms or private cloud platforms. Otherwise, it can be open to any persons from the web. For example, the weather information or some other gateway services can be required. We know that what is the concepts of the gateways. It will control the communications between the hardware devices as well as hardware devices with the cloud platforms. There will be so many types of protocols have been required for communicating between the gateways and the cloud. For example, our HTTP transfer protocols or hypertext transfer protocols or MQTT transfer protocols are examples of some protocols used in your embedded applications or sensor deployment. But most probably, the MQTT protocols are commonly used for the sensor deployment in IoT platforms. We will see what about the MQTT protocols while we are discussing with the cloud deployment in the last sections of this seminar. The next part of your devices is what are the analysis that can be occurred or that can be performed on your the data applications. Okay, that is an option one. For example, if we want to perform some operations or real-time interaction between the different nodes connected to this IoT or IoT frameworks or cloud platforms, there will be some analysis or justification platforms is required. It is nothing but a group of programming. It may be either an open source programming platforms or it may be a proprietary. Nowadays, most of these programming platforms have been replaced with an open source programming platforms. One of the examples of your open source platform is your Python. Right. So many hardware platforms are also available for your hardware deployment. So within this last 3 to 4 years, most of these embedded system platforms and IoT platforms are replaced with your open source hardware and open source programming platforms. As we probably know that what is the difference between the open source and proprietary devices. For example, you can just compare the performance of specifications, performance characteristics of your Windows operating systems and Linux-based operating system. As we probably know that the source code for your Linux-based operating systems are available to be called programmers. So by comparing these versions of Windows-based and Linux-based operating system, we can see that hundreds of operating systems are generated by using under the open source license under the Linux platform, especially reserved for the embedded applications or IoT platforms, not only for your conventional operating system. Most of these developments are done in this operating system is commonly in hardware interfacing or IoT and embedded interfacing applications. Right. So it will be a simple analysis platforms to communicate or control the devices or control the status of the sensors deployed in the patient's bodies that can be controlled from the doctors anywhere from the web. And the last one is what about the user interfaces? Then without these user interfaces, we cannot say that it will be an accurate platform. So it will be a user-friendly platform as an IoT framework. Most probably, what will be the possible or expected forms of your user interfaces? Nowadays, we can able to generate your own applications for controlling the different devices by using some mobile applications. We can able to communicate between the mobile app with Bluetooth devices or Wi-Fi devices with a specific platform. It will be simple applications can be defined by yourself. Similar to there is a application called as application program interface or API, and the most the functionalities of this API is it will provide this real-time interaction between the end users as well as the sensor devices deployed in somewhere else. I can able to control the status of devices which is connected to the things or the first part of your IoT frameworks, and I can read or send some data between the user platforms, either laptops or mobile phones, or any type of APIs can be used as a user interface. Right. So this is a sample major components of your IoT frameworks. Okay. Then what are the different devices can be connected from the IoT framework to the human devices? Already we have discussed what are the different things under this structure. So I'm trying to skip this part. Our ultimate aim is we should have to develop or have to make some information related to the different IoT boards available for different prototyping applications and development of real-time IoT systems or the sensor deployment. Right. There are three broad classifications are related to the IoT development boards or prototyping board. Then first classifications of your systems is called as, it is based on whether the hardware is microcontroller based devices or not. We know that most of the hardware devices or embedded or IoT frameworks are replaced the microprocessor platform with your microcontroller. The first classification is what about whether the hardware module is a microcontroller based board or not. I will familiarize you the recent as well as the most suitable platforms for your real-time applications or real-time IoT frameworks. Okay. The first platform for your microcontroller-based board is called as an Arduino. We know that what about the Arduino board? It is not a microcontroller. It is a development platforms for real-time applications with an open source programming support as well as open source hardware development support. Both software and hardware can be customized by a programmer or by yourselves. That is why the Arduino is most adaptable to the researchers and the teaching community as well as for the project development applications for students from 8th standard to their PG levels and so on. The higher levels of abstractions, the users are trying to develop some hardware platforms as well as the software platforms for Arduino. That is why I think more than 15 or 16 types of Arduino based boards are available in our market. We are not going to discuss about it. We are discussing only two or three boards available under the microprocessor based system. Okay. Then what is the concepts of this Arduino? It is a simple development board called as integrated development environment equipped with Atmega 328 microprocessor. You know that Atmega 328 is the main developer board in 2000 and 1995s, but it is the same microcontroller have been used for developing the open source software and open source hardware platform using the Arduino Ide. Normally, you know that this Atmega 328 is a purely an 8-bit microcontroller. It is reserved for a single piece of hardware, reserved for your embedded and real-time embedded development applications. Right. We can able to write these programs in Arduino platform either in embedded C platforms. Normally, the embedded C is the most adaptable programming platforms for your Arduino platforms. These are some variations of Arduino hardware platforms available in our market. It is varying from Arduino Nano, then Arduino Uno, then Mega, Micro, etc. Okay. Some types of devices have an inbuilt Bluetooth technologies and Wi-Fi facilities also there. But the main drawback of this microcontroller-based systems is that it does not have any operating system support and real-time operating system support. Then without a real-time operating system, we cannot be able to say that your platform it's purely a real-time or most suitable, this equipped with your real-time IoT frameworks. So for a simple real-time embedded hardware developments, this type of Arduino boards are more suitable for your applications. Right? And another variations of the Arduino-based IDE is ESP8266. But compared to these variations of Arduino and ESP8266, it has an inbuilt wireless facility for developing your IoT applications. This one is the first IoT platforms adaptable for development, adaptable for the researchers communities and the students community. Because while we are using these conventional Arduino platforms, we have to use the Wi-Fi modules or Bluetooth separate Wi-Fi modules and Arduino Bluetooth module for different application, depends upon your application. So they have developed a core class ESP8266 with a real-time operating system support with an SDK, as well as it has an inbuilt Wi-Fi facility. But it does not have any OS is not inbuilt into this ESP8266, but it will be most adaptable or useful for your the Wi-Fi applications. Okay. Nowadays, most of these disadvantages of your microcontroller-based systems is that it does not have any inbuilt communication protocols like your Wi-Fi or wireless or your local area network, as well as there is no interface, there is no inbuilt display modules are not available for these 8-to or the previous classifications of Arduino boards. But nowadays, there is a specialized board called as TTGO-T display. It is similar to the basic size or the size of an Arduino Nano IDE. It has an inbuilt 1.4-inch organic LED display. By using this development system, there is no need of to interface your LCD displays or your Wi-Fi facility or Bluetooth, etc. The minimum requirement for implementing a real-time IoT framework is fabricated on a single piece of hardware. It is called as a TTGO-T display. Main attraction of this system is that it has equipped with a 1.4-inch organic LED display. We can able to display more than 12 or 13 number of lines in a single 1.4-inch display of this TTGO-T hardware development. Nowadays, the previous Arduino platforms are replaced by the TTGO-T. That is most useful for this best options for implementing your embedded and IoT platforms without your machine learning applications and artificial intelligence. The only drawback of this hardware systems is that it is not having any operating system or real-time operating system, and the applications of machine learning and deep learning may not be completed or executed successfully by using this TTGO-T. Okay. By adding some hardware modules like your camera devices, it can also be used for your video processing applications or machine learning applications, but the performance may be degraded. So TTGO-T board is not recommended for your artificial intelligence or machine learning application, but it is the best suitable for your real-time embedded and sensor deployment on IoT frameworks without your real-time operating systems and without support from laptops or any other modules or extra features. Right. The next classifications of your controller boards, it is single board computers. That is, we are entering from microprocessor-based board to a single board computers. The main features of the single board computers is it can be equipped with the machine learning and artificial intelligence applications, or vision processing or vision based applications or image processing applications can be executed by using these single board computers. Okay, I will show you one or two types of single board computers are mostly adaptable to the researchers and the students community. And first one is your the Raspberry Pi, and second one is this one is the photograph of your the Raspberry Pi. And second board of single board computer is available for IoT applications is BeagleBoard, and third one is your the Dragon, and fourth one is your Intel Edison and so on. These are the most acceptable IoT platforms for the research community and the students community. Then there are a lot of single board computers are available for dedicated applications in IoT as well as your machine learning or artificial intelligence. But compared to the performances, and I'm trying to select these are the most suitable platforms for your applications using single board computers. Right. The main thing of this type of single board computers is that the microprocessor architecture or controller architecture is purely an ARM architecture. We know that what is ARM? ARM stands for Advanced Host Machine. The hardware architecture is, it is purely an advanced host machine types. Right. So it will give you the maximum amount of maximum clock frequencies as well as the maximum execution time, because it has some types of pipelining features, the features like the pipelining, then parallel execution, etc., compared to your microprocessor-based system. So that is why I am saying that this type of single-board computers are most suitable for your machine learning and deep learning applications, machine learning and artificial intelligence. It is not recommended for these high-end applications. It will be moderate applications can be implemented by using this Raspberry. Okay, I'm not going to give you the detailed explanations of these three. I'll just show you the basic variations or the applications of your Raspberry Pi module with module for real-time embedded and IoT applications. Actually, this Raspberry Pi board has there are multiple variations are available. The recent versions of your Raspberry Pi version is Raspberry Pi 4B. Okay, the total memory size is available in this Raspberry Pi 4B versions is it is up to 8 GB of memories are available with a Broadcom processor supported. In addition to this, the hardware supported, we can see that the minimum the requirements of embedded systems and the IoT and machine learning application can be inbuilt into a single piece of hardware. We are calling this Raspberry Pi module as a system on module. Actually, we know that what about the concept of system on chip? The system on chip means a lot of devices required for a particular or dedicated applications can be fabricated into a single piece of hardware. So that type of hardware devices are called as a system on chip. Nowadays, the concept is improved from system on chip to system on module. So this module has the every features which are available for your laptops and powerful computing platforms is integrated into a single piece of hardware. That platform is called as a Raspberry Pi. It is also an open source development platforms in whether in the forms of software as well as the hardware platform. So this one is the this is one of the best platforms for your machine learning applications and artificial intelligence applications in the moderate structure. This is a figure of photograph of a Raspberry Pi model, 4D model available in this market. You can see that there is a lot of hardware components. I will just summarize you what are the different components. You can just assume that it is a hardware module. It can be replaced with your the motherboard of your laptops or your desktops. So we can see that the minimum requirements of your basic your laptop motherboard or your desktop motherboard had been integrated into a single board of computer, the maximum size of 7 inches into the 4 inches sizes. Okay. We can see that what are the basic hardware modules.
Sir, actually ಕೇಳ್ಕನ್ ಪಕ್ಕದ ಪಕ್ಕದಲ್ಲ ಮೈಕ್ ಮ್ಯೂಟ್ ಆಣದು.
Okay. Okay, if you have any doubts, yeah, any problems, you can just inform me clearly. Okay, now my voice is clear now.
Yes,
Yeah.
sir. Come, sir.
Unfortunately, my mic is muted. Sorry. Okay, these are the photograph of your Raspberry Pi 4. The main main module of your Raspberry Pi version is it is a Broadcom BCM2744 processor with 1 point up to 1.5 gigahertz of clock frequency with 64-bit architecture. We know that it is a purely an ARM architecture. It has equipped with a quad-core processor or 4-core processor. We know that in our laptops or our desktop is having maximum dual core or 2 number of cores are there. But compared to this, your laptop or laptop motherboard or your desktop motherboard, we can see that it is a quad-core processor. Right. The next one is what are the different input output ports. It is similar to the LAN port and USB ports are there. It may be USB 3.0, 4 USB 3 standards ports are there. The LAN port is available or Ethernet port is available. Then we are having some audio output is there. Then HDMI, it is having 2 HDMI output. In addition to this 2 HDMI output, it has a CSI camera port is there. The CSI, it is a standard commonly used for your mobile development. CSI stands for camera serial interface. You can able to interface your either your USB camera to this USB port or this a CSI camera can be connected to a serial connector. Okay. And another one is in addition to this these 2 HDMI output port, there is also a DSA port is available there. It is a serial port. It is digital serial interface or display serial interface. It is also for your interfacing of the display devices like the mobile phone displays or serial interfacing display can be connected to this device, so connected to this port, right? Okay, then there are some wireless technologies are also available. That is your Wi-Fi facility with 802.11 standard, and Bluetooth facility is also fabricated inside a single piece of hardware. Right. So when we're comparing these different ports of this Raspberry Pi module, we can see that the features available in your laptops or motherboard, laptop or desktop motherboard, it is fabricated into a single piece of hardware. Then how this hardware unit is used for your sensor deployment and the hardware interface. But okay, there's a facility. It is inbuilt into this Raspberry Pi board. It is called as, we can see that there is a 40-pin input output port is available in this GPU on this Raspberry Pi. It is called as a 40-pin GPIO pin. It stands for your general purpose input output pin. And these pins are mostly used to communicate between the different sensors from this external world. It may be some digital sensors or it may be some analog sensors may be there, right? Because it does not have any ADCs for this Raspberry Pi, so it is better to interface the digital sensors to your Raspberry Pi using a protocol called as I2C or SPA protocols. You know that what is I2C? I2C or IIC. I2C stands for inter-integrated circuit. It is purely a two-lane digital or two-lane communication standard for multiple devices. I can able to connect multiple devices into these two-way communications in a master slave mode. Your hardware device or your Raspberry Pi module will acting as a master, and up to 128 number of devices can be connected to the I2C or SPA protocol. SPA stands for a serial peripheral interface. Nowadays, most of these IoT platforms or embedded development platforms have equipped with or integrated with these two in the serial communication protocol, I2C and SPA. Right. So that is why this Raspberry Pi is replaced with the development platforms from the laptops and the things. Okay, these are some features of here the Raspberry Pi module. We have already covered this. What are the features discussed in this on this slide? So I'm just skipping from the next one. These are some variations of the Raspberry Pi modules available in your market. You can see that it is varying from Raspberry Pi model A plus to Raspberry Pi 4B model. Okay, you can see that what are the different improvements of the clock frequency. It is from 700 megahertz to nowadays it is 1.5 gigahertz frequency with an inbuilt memory of 8 GBs. Nowadays, this is the latest motherboard or Raspberry Pi board available in your market. It is Raspberry Pi 4 Model B with 3 variations: 2 GB, 4 GB, and 8 GB variations. Right. It is having the same features: communication protocols, then Ethernet, then Bluetooth, the number of USB port. Everything can be better than compared to the previous model that is available in the market. The only one of the important thing we have to remember while we are choosing this Raspberry Pi 4B module is that it required more power, or more power means in the forms of the current level. Up to the Raspberry Pi 3 model B plus, it required maximum 800 milliamperes current or 0.8 amperes of current is enough. 5 volt, 0.5 amperes. But if you are using this Raspberry Pi 4 versions, it required minimum 1.5 amperes of current at the 5 volt ranges, because it has multiple HDMI ports and multiple USB 3.0 standards are available, as well as the features compared to the third version, then second versions, and the base model of Raspberry Pi. It has the high performance as compared to the remaining. That is why it required up to minimum of 1.5 amperes of current levels is required for interfacing your or using your Raspberry Pi model B versions. Okay, there are so many types of Raspberry Pi operating systems are available based on the Linux platforms. We already noticed that Linux is because of this open source development capability. Linux-based operating systems are mostly used for your Raspberry Pi. The basic architecture is called as Raspbian operating system. It has variations like the Noobs, then VC, then Stretch, etc. Okay. In addition to this Raspbian-based and Linux-based system, Windows-based operating systems are also supported in Raspberry Pi. Okay. The next one is how we can utilize your Raspberry Pi module with module for the handheld device development. Right. You can see that this is a simple. Okay, I will show you a photograph of. I will show you the real-time. You can just 1 minute. Try to. Yeah, this is the simple hardware which are developed for your for this current period. You can say this is a single board computers or Raspberry Pi module available. There's 7x4 size of images. Your real-time systems, it may be either in the form of Linux-based or Windows-based operating system, can be loaded into your Raspberry Pi system using simple SD card. You can able to insert your SD card with your real-time operating system, or Linux-based or Raspbian system can be inserted into this SD card slot. That is in that your entire hardware devices or hard disk drive is replaced with a single micro SD card. Right. If you are using these types of displays, this is a simple 7 inches touchscreen display for dedicated for your Raspberry Pi implementation or Raspberry Pi platforms. Either you can use the 7-inch display, or you can use there is another type of displays are available, or TFT displays are available for Raspberry Pi. It is with a maximum size of 3.2 inches sizes. Okay, for the hardware development for devices that can be it's better to choose a 3 inches display that can be placed on the top of this hardware module. So it will be more compatible, the size will be compatible, and that can be portable to any other places with the help of a simple 3 volt or 3.5 volt of battery power supply. Right. Here I am just showing this photograph for a physical structure of a 7 inches display that can be connected to your Raspberry. Okay, so there's an options for fabricating different fabricating or deploying the hardware systems with the help of this 3-inch display, so it can be used with a 7 inches display. So that is why the Raspberry Pi systems is more suitable for this real-time imaging applications and real-time embedded applications. Right. Okay. We are not going to discuss what about the remaining types of embedded or single board computers available in our market, or BeagleBones or Dragon Board Intel Edition. We are just only discussing the Raspberry Pi board, and we will switch into the another possibilities of hardware deployment with GPU support. Okay, my question is whether your Raspberry Pi is having any GPU support, or it has only simple CPU support or not. Okay, but in Raspberry Pi 4 versions and 3B versions, we can see that it has equipped with some type of the GPU facilities or graphics or the features of graphics or graphical processing unit applications can be available from Raspberry Pi 4th version, but it is not that much suitable for your high-end applications or high processing applications. It will support a simple GPU background, but your Raspberry Pi platforms or BeagleBoard is more suitable for real-time IoT frameworks and real-time IoT deployment. Okay, but for moderate type of artificial intelligence or machine learning applications can also be deployed in Raspberry Pi, but we have to remember that the performance may be degraded, depends upon the application areas. So that is why we have to switch from the single board computers or system on module to GPU based hardware devices. Right. We know that the leading manufacturers of your GPU units, it is NVIDIA. Right. Is there any dedicated hardware platforms is available for IoT or machine learning or robotic applications with the support of the graphics processing unit? Do you know what is the graphical processing unit or GPU unit? Or what is the conforms or comparison between the conventional CPU or CPU and general or GPU systems? I will show you a simple structural comparisons of a GPU, then we can go for a more detailed data. Right. In graphical processing unit, normally the leading manufacturers of your GPU units, it is NVIDIA. They are offering GPU units for gaming applications as well as for your the IoT framework and robotics framework. Right. But nowadays we are familiar with GPU support with you. Most of us having the laptops with a GPU support. Actually, it is not suitable for your machine learning applications or deep learning application, because that hardware unit is commonly dedicated for your the graphics processing or the gaming applications, because we are not using these laptops or your laptop systems for your IoT sensor deployment, because we don't have any facility for hardware deployment using your laptops. But it is also possible by using your USB interfacing or serial interfacing facilities. But it required a interfacing platform between the sensor devices and your laptop. That is why we are not recommending this laptop for your IoT sensor deployment. Also, you have to develop, or you have to find out which is the most suitable hardware platforms for your machine learning and artificial intelligence applications. Okay. Yeah. I will show you, I'll familiarize you some example from NVIDIA. That is one of the base hardware unit from NVIDIA manufacturers. It is Jetson or NVIDIA Jetson Nano unit. It is a single hardware, it is small hardware piece. It is also the size with the maximum 8x4 inches size inches, and thickness will be limited to 2 inches sizes. It is also inbuilt with the every features available in your laptops and desktop system. In addition to this, it has a dedicated GPU unit for your artificial intelligence or machine learning, and robotic applications can be integrated into a single piece of hardware. Right. Then what is the specifications of this type of Jetson Nano device, or Jetson or NVIDIA Jetson Nano hardware? You can see that by referring to this structure of how many number of CPU or processors are available in this NVIDIA. While in your Raspberry Pi, the total number of processor core, it is limited to maximum of 4. In our laptops, it is limited to 2 number of cores. Right. In NVIDIA Jetson Nano, it is equipped with 128 number of cores. That is 128 core processor is inbuilt into this NVIDIA Jetson Nano unit. So we can able to assume that what is the performance of this Jetson Nano computer. It is a simple, it is acting as a computer in addition, while you are connecting the USB board or USB interfacing devices like your mouse or keyboard and the display unit. It can be acting as a powerful computing platform for your embedded or real-time or artificial intelligence applications. Now remember that it is dedicated for your IoT framework with 128 core architectures. Then another, we can see that this is the specifications of your Jetson Nano CPU. The GPU unit has is 128 core Maxwell processor. In addition to this, it has an inbuilt memory up to 4 GBs of memory, and connect is another wireless and wired connectivity facilities are also included. In addition to this, characteristics of your conventional GPU board, it has some serial communication protocols and GPIO boards are there. We know that GPIO stands for a general purpose input-output pin. Commonly, it is used to interface the external devices or communicate between the GPU unit and the external sensors. Right. It is also, we can see that it supported 4 types of serial communication protocols like I2C, then I2S, then SPA, and UART. Actually, we know that what about this UART? It is a serial communication protocol, universal asynchronous receiver and transmitter protocol. This is the oldest one. It is common nowadays. It is also used in the embedded applications also. Right. And another one is I2C, I2S, and SPA. We already noticed that I2C stands for, it is I4C, and SPA stands for real serial peripheral interface. These 4 types of communication protocols are also inbuilt into this a single piece of hardware. So you can see that the basic, the total size of that Jetson Nano, it is maximum 7 into 4 into 2 inches sizes. So if you are going for implementing some IoT applications or real-time imaging or machine learning application with the handheld devices, but the basic applications of this type of GPU boards are commonly used in the medical devices and medical application areas. For example, nowadays we know that if you are entering into admitted to the IC unit or the hospitals, especially in IC unit, we are having a huge amount of more than 3 or 4 number of machineries can be attached to a single body. For example, if you want to measure this heartbeat, or I want to measure the different physical parameters, or identify the different levels of the body parameters, etc. But definitely, is it possible to replace that big size data units by using this Jetson Nano unit? Otherwise, if you are entering to this some scanning centers, your X-ray unit, it is a compared to this will be a big one. It may not be it may not be a transportable. Right? Is it possible to replace these types of devices or X-ray unit or your machine learning or devices with machine learning applications, or your computer or the IC units, etc., can be replaced by the Jetson Nano or not? Actually, it is a best suitable options for developing portable devices for medical applications. It is not limited to the sensor deployment, or not limited to the medical imaging applications or something like that. For example, how it is possible to implement this Jetson Nano or GPU for your imaging applications. For example, I want to identify the levels of eye brightness or eye power, or I want to identify the disease like diabetic retinopathy or etc. Because of the diabetic patients, there is a possibilities of the power can be changed, or that is called as diabetic retinopathy. Okay, the conventional methodology, the physicians cannot be able to identify the strength or the depth of diabetic retinopathy and how much it will spread into your eye areas as a naked eyes. Nowadays, they are having some to identify the depth of your diabetic retinopathy or the power ranges or diseases, the eye diseases. They have some chemical materials or chemicals can be used for your eye analysis, as well as some machineries can also be used for the manual identifications or manual analysis of the eye diseases. But your ultimate aim is we have to develop a system with real-time system for the identifications of diabetic retinopathy without the need of the physicians or ophthalmologist. Right? So if we are trying to develop a machine learning applications or machine learning framework using this Jetson Nano unit, we can replace these existing methodologies or existing machineries with a handheld devices with the maximum weight of 500 grams or 400 grams. So in the future, in the near future, most of this medical field are replaced with the physicians or the radiologists or ophthalmologists or technicians, etc., can be replaced with this machinery. So there is a big opportunity for dealing with the GPU-based systems for the development of machine learning and artificial intelligence devices to identify or predict the some type of diseases. It is not only result for the identification. By using these machine learning technologies or deep learning technologies, using these powerful platforms, we can able to predict the occurrences of the particular diseases, especially the predictions of the heart diseases, the predictions of the diabetic retinopathy or diabetic diseases, or the predictions of the occurrence of the blood glucose incrementing, etc. Or even we can able to predict these stroke also, because if you are placing some sensors to this human body and with the help of this GPU processes, this type of prediction algorithms or prediction machinery can also be implemented with this Jetson Nano GPU hardware, because we already noticed that it is equipped with a 128 core architecture, dedicated architecture with a GPU structure. Right. And another types of devices commonly used for your it is available from NVIDIA manufacturers or vendors is that it is first one is your Jetson Xavier NX, another one is Jetson AGS Xavier. I'm not dealing with the all types of GPU boards available for IoT application. We are just dealing with the low cost hardware devices available from this vendor. The next type of hardware board is Jetson Xavier NX board. It is the physical size of that NX or Xavier NX is same as the Jetson Nano, but the performance is very different. The total number of GPU cores or GPU core available in Jetson Xavier it increases from 128 to 358 number of cores. That is 128 to 358 cores of core GPU is available in this Jetson Xavier NX model. Right. Comparing these price levels of this to Jetson Nano is available with a average price of an 8,000 or 8,500 rupees, and Jetson Xavier is available with 22,000 rupees because it is having a qubit 328 number of cores, and also the memory size is improved from 4 GB to 8 GB. Then other performance, other parameters also may be improved compared to Jetson Nano. I'm not dealing with this. And third type is Jetson Agx Api. Normally, this Agx Api is dedicated for the hard deployment of robotic applications and artificial intelligence applications. But your Jetson Nano or Xavier can also be used for this type of application. But their dedicated framework or architecture is reserved for Jetson Xavier and Jetson Agx. We already noticed that Jetson Xavier is more suitable for the cloud applications and artificial intelligence, and Jetson Agx Xavier it is reserved for the hardware deployment in artificial intelligence and the robotic applications. Right. The total price of this Agx Xavier is up to 98 or up to 1.5 lakhs rupees for a single piece of hardware. It is a worthy hardware for your real-time robotics applications and artificial intelligence. But nowadays, the laptops and hardware units for artificial intelligence devices can be replaced with the Agx Xavier because it has up to 512 number of GPU cores are available in this Agx Xavier. In case of Jetson Nano, it is 128. Jetson Xavier is 358, and Agx Xavier is having 512 number of GPU cores. Right. These are the some hardware development boards available for your artificial intelligence and the machine learning or IoT frameworks. Our third topic is what about the different cloud platforms for Internet of Things. Okay. By comparing the major components of your IoT framework, we can see that first one is the sensor devices. Second is the hardware interfacing platforms for IoT, and third unit of your IoT or IoT framework is the cloud architecture. Right. We will discuss what are the different types of cloud architectures or service providers are available as a free of cost, and which one is more suitable for your real-time sensor data deployment and deployment. Right. Actually, what is a cloud architecture? Normally, we have fundraised or always we are hearing this term called as a cloud platforms or cloud architecture or Amazon Web Services or Cisco IoT, etc. Then, what is meant by the cloud platforms for Internet of Things? Actually, it is a massive network of devices or IoT devices that can be communicated between the sensors and actuators, or we can try to develop some applications including the server devices, then storage devices, then real-time processing applications and so on. It's a huge number of sensor devices or deployment platforms, then analysis platforms, and API or user fronts are combined into a single group of systems which is called as IoT cloud platforms. Right. We will look into this. What are the possible different types of cloud platforms available for your real-time sensor deployment and real-time image deployment applications. Right. First one is the Microsoft Azure IoT. Second one is Google Cloud IoT platforms, and then IBM Watson IoT platforms. Right. Actually, what will be how we can choose these types of cloud platforms for the particular applications? Normally, I think there are 10 plus or 15 plus number of cloud or IoT cloud platforms are available in this era. But which one is most suitable for your research applications and students development applications? I will familiarize you 3 or 4 types of platforms most suitable for your hardware deployments and the sensor deployment. The first one is the Microsoft Azure IoT suite. Second one is your Google Cloud IoT platforms. Third one is IBM Watson IoT. Fourth one is AWS IoT, then Cisco and ThinkSpeak. Right. Normally, the researcher community is adopting these AWS platforms and AWS platforms for their sensor deployment. And the students community adopting for this ThinkSpeak or Firebase or Google cloud-based platform for the sensor data deployment. Google Cloud platforms called as a Google Cloud platform. The complexities of configuring your cloud interfacing, it is very easy. There is no complexity. We have tried to generate a user account and provide some and take some API keys or application program interface keys or secret keys for deploying the sensor data to the ThinkSpeak cloud or your Google Cloud services. It is a very, compared to these 6 types of IoT platforms, IoT cloud platforms, AWS, the ThinkSpeak and Firebase cloud or Google Cloud is most suitable for your student applications. Right? But what about these researchers and developers? Researchers and developers are commonly using this AWS or Amazon Web Services or AWS IoT platforms. The configuring these AWS platforms is it is a little bit difficult as compared to your ThinkSpeak and Google Cloud platform called as a ThinkSpeak. Right. First, we have to provide, in case of AWS platforms, we have to give some securities or security amount for their accessing the cloud services, and we have to separately configure the different platforms available inside this AWS called as a buckets or something like that. Right. For research applications, we are recommending these AWS platforms for the sensor deployment. For students project or the development students project applications, we can use ThinkSpeak or Fire-based cloud platforms or Google Cloud, Google Cloud Firebase platform for the sensor deployment. Okay, these ThinkSpeak or Google Cloud or AWS, every these types of platforms are both supported these imaging applications or the digital sensor interfacing or sensor deployment or communication between the APIs and the sensor platforms, etc. The two-way communication is also supported by using these types of platforms. The two-way communication, I mean, I can able to control the hardware devices which are fabricated in somewhere else or some other geographical area. Through these IoT platforms, I can able to control the status of hardware devices or sensor devices remotely. Okay, before going to this, I will show you the photographs or the physical hardware or the physical setup of your Jetson Nano hardware, which is available here. Yeah, I think, this is a hardware module, is Jetson Nano hardware module available with me. You can see that the input output ports of your laptops is available in the one side of the hardware module. You can see that it is supported your VGA output, then LAN, then USB 3.2 standard or 3.0 standard with a maximum 4 number of ports are there. Right. In addition to this, similar to your Raspberry Pi board, it is also having some type of GPIO board, or this we can say this is a 40-pin GPIO pin available in your Jetson Nano. Mostly these GPIO pins are used to interface the sensor devices or the devices from this external world, especially in the form of the digital communication data. But also it supported the analog sensor interfacing with an additional analog to digital converter. That is one of the disadvantages of the IoT development board, either in single board computers or GPU based computers, is that it does not have any analog to digital converter module, for example. But in sensor interfacing or IoT deployment, one of the main features for the hardware is it should have equipped with the analog to digital converter while we are dealing with the analog devices. But already we notice that nowadays your analog devices are already replaced with some digital sensors. We can able to interface multiple number of sensor devices to a single line of communications called as I2C and SPI protocol. That facility is also available in this platform. And in addition to this, we can see that there are two serial interfacing ports are there. While we are discussing with your Raspberry Pi, it is also having two serial interfacing port. Here we can connect the camera unit, and this port is commonly used to interface digital serial interface or DSI display unit. Right. Similar to this Raspberry Pi board, here is also having two serial port outputs are there. First port is reserved for your camera serial interface. I can able to connect the camera unit like this. You can see that this is the examples of a CSA camera available in your market. You can see this. This is a photograph of a CSA camera commonly used for your Raspberry Pi module as well as for your the Jetson Nano or NVIDIA Jetson Nano. You can see that this is a flat ribbon cable. It can be connected to the one of the ports of your Jetson Nano GPU as well as your Raspberry Pi board. Then another port is reserved for your camera serial interface or digital display serial interface or DSI port. Okay. Here is also I can able to connect this some touch display unit or the mobile display unit with a flat cable connection to this port. So if you are using USB keyboard or mouse and your CSA camera as well as your DSI display unit, and this single piece of hardware can be acting as a powerful computing module reserved for especially used for your artificial intelligence or machine learning or IoT applications or embedded system. Okay, every features are available on here, right? And here we can see that inside this, behind this heatsink unit, this is a GPU or your 128 Jetson Nano GPU core is fabricated under this heatsink, right? Then where we have to dot this operating system for Jetson Nano GPU. We already noticed that in case of Raspberry Pi, a simple micro SD card is enough to load or enough to upload load your operating system either in Linux operating systems or Windows based operating system. Similar to this Raspberry Pi system, your GPU or your Jetson Nano GPU is also equipped with a micro SD card. You can see that if you are trying to remove this GPU or this GPU or SD card module, this SD card can be loaded with your Windows based operating systems or Linux based operating system. So nowadays you already notice that your GPU or NVIDIA systems is also loaded with the Linux based operating system. It is having dedicated Linux based operating systems is available for you. NVIDIA Jetson Nano and NVIDIA or Xavier or Agx Xavier also. So these are the some type of development boards commonly available for your system on module or GPU based hardware interfaces. Right. And another one is I will show you simple applications of before going to the deployment platforms. I will show you one of the applications of microprocessor based systems for your embedded and IoT deployment. Okay. We are trying to switch from your GPU to single board computers and single board computer to a conventional or TTO T display. You can see that this is a conventional or the TTO T display with 1.4 inch organic display available in your market. It is commonly used for IoT applications with Wi-Fi facilities and the Bluetooth facility. You can see that it is the same physical structure of your Jetson, Arduino Nano. I think most of them are familiarized with a Jetson Nano module. This is the simple Jetson Nano module, and this is your hardware model of your TTO-T display with a basic architecture of Atmega 328 microcontroller. Right. We know that this Jetson Nano does not have any Wi-Fi facility or Bluetooth facility, but it has inbuilt Wi-Fi and then Bluetooth, inbuilt LCD, organic LCD display, etc. Okay, so that is why the TTO displays are now commonly used for your IoT sensor deployment application, not suitable for your the machine learning. But I can able to interface your camera unit with this TTO display. Right. Then I will show you a simple what will be the performance of the TTO display available for that is performance of a TTO display. Right. Then we can get this more idea about how much clarity will give from this TTO-T display. We'll try to connect it. Yeah. You can see this. This is a symbol. Yeah, photograph of TTO-T display interfacing. I'm not trying to connect this any one of the sensor to this unit. I'm just displaying this some parameter like the date and time, then some strings like product development week 2020-21 and so on. Right. So we can get this maximum clarity, and we can define the color of each and every characters because it is an organic LED display. Right. Okay. Then I will show you a sensor, some deployment for use the sensor deployment using the TTO-T display or TTO-T hardware. Right. Okay. Then have you familiarized the hardware unit commonly used for measuring the body temperature using infrared technology. So I will show you a device photograph, then we can go for the sensor deployment in TTO-T display for. Okay. Actually, this device is more familiar to us for the last 2 years because of this COVID. Right. Normally, there is a technology how can measure this body temperature in conventional methods. Normally, the body temperature sensor may be measured by using some mercury-based systems or integrated circuitry or chip-based system. Always till this COVID-19 period or the booming of this COVID-19, we are not familiarized with the non-invasive type temperature measurement. The non-invasive, there is no physical contact is not required to measure this temperature. But before that, so many electronics types or types of electronic sensors or electronics gadgets are available for measuring the body temperature. But that sensors are not non-invasive. It is an invasive type. It means there will be a physical contact between the sensor and the body structure. But nowadays, most of the hospitals and education institutions and every shopping malls, etc., have equipped with this sensor or this type of unit for measuring the temperature of the human body. Okay. I will show you what is that type of sensor commonly used in this non-invasive body temperature measurement. Then I will show you what is the basic working principles, and we can go for the deployment of that sensor. Yeah. You can see this. This is a sensor used for your non-invasive temperature measurement of the human body. The name of the sensor is MLX sensor or MLX 20614 sensor. It is reserved for the non-contact body temperature measurement. Then how it is possible to measure the body temperature without the contact with the physical sensor? As we probably know that there is this is the MLX 90614 sensor. We know that every human body will emit some amount of infrared radiations. Okay, that is why we are using some CCTV camera with IR cameras or IR CCTV cameras. Right. By using this IR CCTV camera, we are trying to measure the presence of the IR rays even in the night time or the black regions also. Right. We already familiarized the concept of the IR CCTV cameras. The same principle is used in the MLX 90614 sensor. We know that every human body will generate some amount of infrared radiations with a single frequencies of lambda is equal to 7.5 lambda frequency. Right. But what about the animal bodies? Animal bodies also having some heat will be generated in the form of IR rays, but the wavelength of that IR rays will be different than the human body. So we can able to differentiate the IR rays falls on this sensor is whether it is in the frequency of the human IR range or it is the frequency of the animal body. So this is the MLX 90614 IR sensor is also for the human body IR measurement purposes. Right. So it will sense the presence of IR rays within the frequencies of lambda is equal to 7 to 7.6 lambda frequency, and it will try to convert this energy into IR energy into some voltage levels. But okay, the output of the sensor will be some voltages. That voltage can be measured by using your microprocessor-based systems or GPU-based systems or single board computers or system on chip. Any type of microcontroller or microprocessor can be able to read the output from the MLX 90614 sensor. So I can be able to identify the presence of these IR rays. Right. So that voltage changes can be converted into the human body temperature, animal body temperature, or it can also be able to identify the presence of the human presence in a particular premises. Right. Okay. I will show you one of the examples of how to measure this human temperature using this MLX 90614 sensor. Okay. Nowadays, this is a simple hardware module or hardware devices available in our market for body temperature measurement. I'm trying to keep it as it is configured into a single unit task like this only for your demonstration purposes. I am just installing this MLX 90614 sensor on here, and here is also we can see that there is another sensor module. It is used to identify the heart rate and SpO2 levels. Right. I'm just trying to imitate the that development that hardware modules for screening devices by using our own hardware unit, and this is the MLX 90611 sensor. It is a sensor named as MAX 30102 sensor. The output of this MAX 30102 sensor will provide both the temperature of the human body, then SpO2 levels or your blood oxygen level, as well as the heartbeat of that body. Right. It is also this one is a non-invasive sensor, but it is required. This MAX 30102 sensor required physical contact with the sensor. Then only it will give you the accurate value. It is also a sensor sense the SpO2 level and heartbeat sensor without the contact with this sensor unit, but the accuracy will be not much satisfied. But the sensor unit, that this IR sensor or MLX 90614 IR thermal sensor will provide you both the non-invasive measurement as well as the invasive measurement. Okay, if you are having maximum 3 to 4 centimeters of distance between the sensor and the human body, it will give you an accurate measurement. Right. I will show you how to measure this my body temperature and heartbeat and SpO2 levels using this sensor. I am using this different sensor for temperature using MLX 90614 sensor, and heartbeat and SpO2 levels by using this Max 30102. The reason is that I have to just memorize multiple sensor for your application. Normally, this sensor is not required for measuring your body parameter. This Max 30102 sensor will also provide you the body temperature, SpO2 level, and blood heartbeat of your human. Right. So just I'm trying to just clear it and show you what about the changes. Yeah. Okay, you can see this. I think it is visible to you. Yeah, now it is visible. You can see that my body temperature is 36.05 degrees Celsius. It is equivalent to 86.65 Fahrenheit, and heartbeat is BPM, that is yellow color heartbeat. The bottom layer is BPM is 76, and SpO2 level is up to 91 and 92%. Right. By using this, I am trying to just leaving this part from my finger is removed. You can see this heartbeat as well as SpO2 levels is decreases, and what about the temperature? Now the temperature is equal to 29.06 degrees Celsius, because I'm just keeping my fingers away from the sensors, so the efficiency will be not that much satisfied. When I'm placing this my fingers on the top of that sensor, you can see that my heartbeat is constant, is 72 or 78 and 80. SpO2 is equal to 92 and 93%, and temperature is constant up to 28 and the 29 and so. Right. You can see this. My finger is based on that. It is increases from 27 to 32 and so. Right. This is one of the applications of your TTGO2 display with the Arduino background can be used for the sensor deployment for different applications. Okay, after interfacing this sensor to this MLX 90611 sensor, I can able to deploy the data from TTGO2 display to either the cloud, which can be available from here, the ThinkSpeak or Firebase interface. Right. I will show you a basic architecture for that sensor deployment. Then we can go for the hardware or the real-time sensor deployment using the temperature and image processing applications. Right. You can see this. This is the architecture I have defined for your MLX 90614 sensor. This is the data from MLX 90614 sensor. It is purely a digital data that can be connected to this Raspberry Pi systems using two-line communications called as serial data and serial clock. Normally, there are only two lines are required for serial communication interfacing. First one is the data, and second one is clock. We know the data is information, and clock is used to synchronize the communication between the hardware Raspberry Pi module or just a nano GP with your temperature sensor. Right. Then, what are the programming or open source programming platforms deployed in Raspberry Pi platforms for measuring the temperature from MLX 90614 sensor. Right. I'm trying to develop a hard software platforms with an Avaron module or open source programming methodology. Have created 3 files of structure. First one is we have to initialize the MLX 90614 sensor using the IoT.setup.py. That is py is the Python. Yeah, I'm trying to use the Python platform for open source program development or open source development. Okay, we are not going to develop a hardware, only for your open source software platforms. So there are 3 files are there. First one for your initialization process. Second files I have created for reading the data from the sensor to your Raspberry Pi. We know that the data packet have so many information, meta informations like your temperature values, then start bit, then stop bit, error control check bits, then synchronization signal, etc. We have to extract this original information from the data packet by programming otherwise. So I am trying to create our own files or our own header files or modules by the concepts of an open source program. This is the second one, that is IoT.I2C read.py. Right. Then another one is I am trying to interface the display. It is not video. I am trying to interface an organic LED display with the Raspberry Pi. Okay, actually the Raspberry Pi can able to directly connect it to the touch screens or DSA display. So on that purpose, the cases it is not required to develop an interfacing platform with your display devices and Raspberry Pi. It will directly connect it to either DSA port or HDMI port. Right. But in this case, I am trying to just generate a small display with a maximum 3 centimeter of size into 3 into 1 centimeter size, only for this only for the size reduction purposes. So I am trying to generate a specialized programming window or module for organic LED display. That is not matter. And this 3 number of open source programming environment have been inbuilt or deployed in this Raspberry Pi for the unit. Okay, only for the interfacing between your sensor and communication between this internet. Okay, then what is the next process? We have to send this information or data from your Raspberry Pi to internet. Okay, there are 2 options are there. We can there are 2 protocols are is necessary for communicating between the internet services and your Raspberry Pi Raspberry hardware module. And first one is your HTTP protocol, that is hypertext transfer protocol. It is commonly used for sending some information or transferring the data between the different units or between 2 units. And another one is MQTT protocol, that is MQ transfer protocols, commonly used for the sensor data interfacing between the node and the internet service providers. Right. The next process is I am trying to create a cloud platforms using this Firebase platforms. There are so many options are there. We can use AWS or ThinkSpeak or Firebase. Anything can be implemented. I am trying to implement the cloud platform using the Firebase interface. Actually, the Firebase is an option from your Google services or Google cloud platforms, and this data which is stored in this Firebase cloud services can be accessed to the service providers or the services available for these hospitals or the nursing stations, then physicians or end user. End user can be any user can be access the data from this Firebase through this internet facility. Okay, this is the cloud interfacing between the different type of end users. Right. In addition to this, I can able to copy or I can able to save the meta informations of these patients on a separate repository. I am trying to represent as a healthcare repository. It may be a server-based system, or it may be a web pages, or any type of storage medium with a high data security or with some type of password security or hacking protected circuit, etc. That can be implemented out here, because the informations of the patients will be or meta informations collected by using these sensors, a number of sensors that will be saved into the healthcare repositories, or it can be saved to a Firebase cloud, and everything can be accessed to this end user only with the permissions or with some password security systems, etc. Okay, this is simple architecture of how to deploy your sensor data information to cloud repository using sensors and cloud interfaces. Right. I will show you simple interfacing or the how to prepare a cloud services using ThinkSpeak repository or ThinkSpeak cloud services as well as Firebase services. Right. Now we can assume that I am going to create a cloud services using the Firebase. Or first of all, we can go for the ThinkSpeak IoT framework. Okay. For that purpose, you can go to ThinkSpeak. That is THING. Now think it is ThinkSpeak. You can go to the ThinkSpeak cloud or IoT analysis and create a channel by using your email ID as a for accessing these services, right? So the best step is we can go to the thingspeak.com and create an account with your credentials like the password and the email security. Okay, it will open up the channel or window, something like that. This is the ThinkSpeak cloud window. It will be open as like this. Okay, first we have to create a login on ThinkSpeak account. Then go to these channels and create a new channel. Okay, then they will ask you to what is the name of this channel. By clicking on this new channel, I'm trying to generate a channel called as simple, I can say XYZ. That is my channel name is an XYZ. We can give this whatever description, it is not mandatory. Then you can choose how many number of fields are there or required for your channel. In this case, I am just trying to upload the temperature. You can assume that I am trying to implement a health monitoring system for the ICU patients or health monitoring system for or wearable health monitoring system. So there will be so many parameters are there. For example, the temperature, then heartbeat, then SpO2 levels, then glucose levels, etc. or a positive or respiratory, etc. This that depends upon the number of parameters we have to upload. You can choose how many fields are there. And the first channel default, I can able to rename this field as temperature. Okay, right? With your ThinkSpeak channel. Okay, you can see that there is a external link is provided on here. This link can be used to provide the your customized website channel or website. The next case is link to the GitHub, right? Okay, GitHub, we know that GitHub it is a repository, it is common repository for embedded applications or real-time systems. Sit down, this. Okay, just 1 minute, I think. Yeah. Is my now it is visible. Okay, the first case the ThinkSpeak does not connect. Okay, you can go to the ThinkSpeak and name your channels and give this how many number of fields are required for your particular applications. Okay. Then another option is you can able to give this link of your GitHub account. You know that GitHub is a repository for your embedded or IoT, machine learning, and artificial intelligence applications. But nowadays, GitHub is more familiar to us. I think before 2 to 3 years back, GitHub is not at all acceptable for these programmers and developers. But the recent 2 years back, GitHub is it will be most adaptable repository for the developers and the scientists, because I can able to share my experiences or share my programs or development platforms or sensor deployment concepts with the research community by using this GitHub repository. Right. If it is possible, you can give the link of this GitHub repository. Then next possible options is it possible to interface the video interfacing platforms with your ThinkSpeak? Okay, I can able to real-time streaming of videos either to the YouTube channel or Vimeo channel can be possible. Okay, if you are trying to use this YouTube, you can give the channel link of your YouTube. Otherwise, you can create a separate video uploading platforms by using this Vimeo APIs. Okay, that can also be supported, and you can just save the channel. Right. Okay. Now I'm trying to create a channel with the channel name of XYZ and channel ID is 1520370. That is unique for your particular project. Right. Yeah, you can see this. I have created two channels, two field with a name of my channel is equal to XYZ. Here we can see that this is the name of my channel XYZ and field 2 and field 1 is there. That is, I have already created maximum two chat fields are there. First field name is called as field 1 and second one is field 2. Right? That's possible. The next possibility is whether I have to switch this view to some other numerical representations or graphical representations or needle representations, etc. Right. You can see that there is a additional button called as an add widget. By clicking on this, they will give you three options for displaying the channel value. First one is I can able to display this temperature in the gauge format, or it can be the numeric display. Okay, there is another Lambda indicator. It is only for simple logic system, or logic high or logic low indication. For example, if I am trying to find the status of a sensor devices or devices, for example, I want to find the status of whether my door is open or closed. Right. There are two options are there. If it is closed, output will be low. If the door is open, the output is equal to high. Okay, that presence or that conditions or status of that door can be represented by using this Lambda indicator. Right, by using this red color and the green color, I can able to indicate it by using the logic representation, the Lambda indicator. If I am using this numeric or gauge factor, it will give you it is suitable for your the temperature display. This time choosing this numeric display and click next. Right. Here I have to set this configuration of that widget. You can rename the widget or field 1 or name. And next one is I have to set this update interval of my channel. My channel is update interval of the temperature value. Okay, minimum it will record minimum 50 seconds. I can able to increase as with 15 or 20 seconds or 30 seconds up to 15 or 20 minutes of things can be 20 minutes of durations can be set by using this update interval time. Right. And next one is what about the unit? I have to represent the unit either in degrees Celsius or kilograms or centimeters or RPM, etc. That depends upon the sensor data. You have to give the unit of that information. Right. The next one is whether I have to represent the integer or decimal format. If it is a decimal format, you can choose how many number of data can be placed after the decimal point. Otherwise, it will be an integer value. Depends upon the sensor data. You can choose which one is more suitable to configure the corresponding widget. Then you can create it. Right. Yeah, then we can see that there is another field 1 numeric display is created, but the field value is not available because I'm not updated anything to my channel. Right. Then before going to the programming concepts, we should have to configure some other parameters. And then first parameter is whether that channel is public or private. Right. It is a public cloud or private cloud. If it is a public cloud, anyone can be access these parameters by knowing your channel ID 152037. It is unique for your particular channel. Okay, by knowing this channel ID, I can able to anyone can able to access the information from your channel. Okay, then how can set this channel as a public as well as how to channel as a private cloud. Normally, the cloud configurations and things speak, it will acting as a private view. If I want to set it as a public view, you can go to this. Now you can see that I am selecting this public view. This channel is not public. We cannot able to view the data or sensor data of my channel without my permission. So that purpose, you can go to the sharing window and choose who are able to access your channel parameters. And first one is keep the channel as a private one, then channel with everyone, and channel with the following users. If I am taking this everyone will access the channel parameters by using this channel ID 152037. The next parameter, the next possible options is we can set this access for a limited users. by giving the email ID created by using ThinkSpeak channel. There are three options out there. Okay, these are the pre-configurations required for your the ThinkSpeak channel. Okay, then we can go for the programming purpose. So if you want to program or update your data or sensor data deployment to this ThinkSpeak channel, we have to get this some API keys or application program interface keys that is unique for each channel that can be generated from this button API keys. Right. Here we can see that there are two API keys are there, API key for write applications and API key for read applications. The write API key is reserved for your to write something to the ThinkSpeak cloud levels. It may be at a private or public. And this read API key is used to read some values from your ThinkSpeak, or for example, I want to read the data or read the sensor data from one of the channels called as channel A1. Okay, depends upon the channel A1 output, I have to control the devices connected to the my channel XYZ. Okay, so that purpose, first of all, I have to read the data or information or the status of that sensor from the channel A1 and process it or analyze the data from channel A1. It depends upon this analysis, I have to send some data to my cloud or my channel named as an XYZ channel or field 1 or field 2. Then depends upon this data sent to the field 1, the devices connected to my channel can be either operated or it will be going to the off state or on state. Right. For example, if you want to control the status of the door opening system by using a single button from this ThinkSpeak channel, by clicking on that channel after configuration, the devices connected to the Raspberry Pi unit or your GPU modules or your Arduino modules, it will control the status of that door, whether it is in the off, whether it is in closed state or in the open state. So I can able to control the status of any type of sensor devices connected to the node 1 through this ThinkSpeak cloud services by using this API interfacing. Okay, then by using these API keys, I can able to read or write something to the ThinkSpeak cloud. Right. Okay, then next thing is how you can interface your data from the sensor devices to your channel. Okay, I will show you the photograph. Okay, I will show you the hardware configurations I have already set up for measuring the temperature by using this Raspberry Pi unit. Here I am connecting your temperature sensor. This is a MLX 90614 sensor, which is connected to the one of the Raspberry Pi pin of your Arduino module. Yeah, we can see that this is the GPIO pins of your Raspberry Pi module. Here I am trying to connect this VCC, then ground, serial data and serial clock of this MLX 90614 sensor to the I2C pin of your Raspberry Pi. Right. And this is the my 7-inch display unit, which is connected to the Raspberry Pi HDMI port. We can see that this is the HDMI port and connected to one of the terminals of your LCD display unit. Right. I will show you the program, then we can go for the sensor deployment is possible or not. Okay, I think my display is not that much big. It is only 7-inch display. Okay, I will share you the program for your testing purposes. The only modification that we have to perform on my program is we have to change. Yeah, we have to change the key of the channel. Already we have copied from your channel, right? I think it is, yeah, just 1 minute. Yeah, here we have to place the API keys or API write key of your channel. Okay, here I am trying to import the necessary modules required for the operations. Okay, normally, what you mean by this import OS, import globe, etc. Normally, while we are dealing with your embedded C or C++ or Java program, first of all, we have to import some header files, for example, hash include stdio.h or hash include math.h. Then only the functionalities or functions under the math.h or stdio.h will be working. Similar to the header files in your conventional C or C++ program, the Python header files is called as modules. Right. Here I am trying to import 4 modules. Then first one is import OS, that is operating system related files can be imported. And second one is globe, and third one is time, and fourth one is HTTP library and URL library. Here I am trying to communicate with your cloud services using HTTP protocols. That is why I am trying to import this HTTP library and URL library for these applications. Okay. Then thereafter I have to we have to place or have to keep your API keys on here. That is keys equal to maybe it is some the combinations of the letters or characters. That is not simple, not permitted. That will give you yeah, this is the address of this is my channel API. I will show you the API for my channel. Okay, I'm trying to by going to this API keys, you can see that we are having different API keys for write and unique APIs for your read operations. So you have to keep this write API key for your applications and paste on here. That is keys equal to, in single quotes we have to place your API keys. Right. Thereafter, I am trying to read the data from your MLX 90614 sensor and send it to this cloud service or cloud by using this program. I think it is not required to explain this parameter because may not be get more information. So I am trying to skip this part. And after executing this program, the real-time sensor data will be deployed to the channel we have already created on this ThinkSpeak account. Okay, I will show you. I will just go to my channel. There is some, you can see that the temperature, it is not the real-time temperature, it is the temperature I have uploaded just 3 to 4 hours before. You can see that I have created 2 field 1 chart and another field by using some numeric indicator. I have just put the name as temperature underscore IPL IBC. Okay, there is the temperature 25.8 degrees Celsius is uploaded on this particular window. At the same time, the graphical representation is plotted on this chart or field 1 chart. Okay, these are the, you can see this by clicking on this point. You can see that what will be the temperature and what are the meta informations of that temperature value. For example, the Tuesday, September 28, 2000 today, lunch time of 12:55, I have uploaded my temperature as 31.437. It will be accessible to either as in private form or it can be as a public form. Now it is I am trying just to configure my channel as a public form. So anyone by knowing my channel ID, they can able to access the sensor data. Okay. Then after, here is another temperature value. It is updated in 12:53 PM with a temperature is equal to 25.812. Okay. By clicking on this graph, I can able to give this meta information or information related to the time and date can be available from here. Okay. That this information may be useful for the physicians also. Okay. If it is a private cloud and it is configured for your physicians and you are trying to generate or design wearable devices, already we have discussed with the TTOT display. The physicians can able to monitor the temperature ranges from their laptops or from their mobile phones in a geographical area. So the meta information also can also be measured by clicking on this panel. Okay. Otherwise, if you are placing this window as a numerical or integer value, it will just display only the current temperature of the human body. Okay. If you are trying, okay, the same example can be implemented for the COVID-19 isolated patients. For example, most of the time the COVID-19 patients are always isolated from the hospitals, or they will be kept inside a closed room. Right? And how it is possible to identify whether that patient is in ideal state or it will be a dangerous state. Okay, there are most of this time the physicians are measuring the three parameters. First one is your body temperature, second one is your blood oxygen level or SpO2 level, third one is the heart rate. Okay, by using the previous hardware module with your MLX 9061 sensor and MAX 30102 sensor along with your TTGO display, it can be acting as an IoT based COVID-19 patient monitoring system with a minimum amount of hardware complexities and software development time. So this product can be given to the isolated patients, and the physicians or these authorized persons can able to monitor their current status either in heartbeat or SpO2 or temperature or any of the physical parameters. Using this a simple hardware unit can be implemented. Okay, that is one of the how to deploy the recent IR based thermal sensors and heartbeat sensor or SpO2 sensor by using this either by using your Raspberry Pi module or TTGO display image. Okay, if you are trying to generate a wearable devices, TTGO display unit is more suitable because it is more compact and more beautiful display with a organic color LED displays available. The patients also can able to analyze their body parameters with a 1.5 volt of battery backup. Okay, most of this case, the main attractive feature of this, what about the power consumption of the hardware unit or the wearable devices we have already developed. So by using a simple TTGO and MAX 30102 sensor, we can able to deploy the informations of COVID-19 patients to the ThinkSpeak Cloud or AWS platforms or Firebase platforms, etc. Okay. Otherwise, we can also develop this or deploy this type of sensor data by using this Raspberry Pi module, or if you want for high-end applications like machine learning or artificial intelligence, you can use the NVIDIA Jetson Nano GPU modules also. Okay, these are the points we are planning to discuss under the first day of your product development week. There is one or two points also we have missing. That is how to deploy or how to interface your video images or video and images to Firebase Cloud or ThinkSpeak Cloud. I think it is required more than 20 or 15 minutes is required for that piece. Later we will try to share the video graphs of how to deploy these images and videos to Firebase Cloud platform for detailed expansion. You can coordinators will share you the video, and you can try to develop your own systems for using either Raspberry Pi or Jyothi or Jetson Nano GPU. Whatever the hardware module adaptable for your project applications, or like some academic project or research project applications. Right. I think it is better time to wind up your sections. I will hold on here. If you have any doubts or queries related to the software and hardware deployment for IoT frameworks, you can interact me, and any informations or any technical knowledge required related to this topic or beyond this topic, you can ask me. I will try to give the clear clarifications of doubts. So just I try to hand over the sessions to my dear students and teachers or my participants. You can interact or ask any questions or queries. Okay. Or if you are having any difficulties facing, you can post your queries on the chat window also. Okay, I will consider this also. Participants, you can ask any questions related to my topic or beyond this topic. I will try to give you clear clarifications. Okay, there is one mail we have to. Okay, we will share these materials either both in the forms of PPTs or your programs as well as the video. Everything will be shared by the coordinators. Or maybe tomorrow or thereafter tomorrow, depends upon that time. We'll share you everything. Okay, there is one question from. Just 1 minute, I have to do this. Okay, is there an internship available for these students? And yeah, actually, this is a program sponsored by the IEDC unit of Jyothi College of Engineering. Here it's also we are having different departments are offering the internships under the leadership of the government approved institutions like DACs, the NEST, Informatics, etc. By as per these topics, we are offering the internships for the inside or in-house students as well as the outside students in the field of embedded system design using Arduino platforms, then Raspberry Pi, then open source programming, especially in the development of open source hardware and software development, then machine learning applications using Raspberry Pi and NVIDIA Agx Api, as well as the deep learning applications and artificial intelligence application, the levels of BTech, then PG levels, as well as the technical support is also given for the researchers and the developers also. Most of the programs are supported from the government of Kerala, or otherwise it is sponsored from the IEDC. Some programs will be deferred based with a small amount of fees, but most of the programs for internships provided from our IoT lab for Internet of Things and Machine Learning lab it is fully equipped with the hardware devices commonly used for IoT deployment and artificial intelligence and machine learning, including the GPU platform support. Most of the programs will be offered by using IEDC or some other government organization. If it is not sponsored, you have to pay some amount. That can be open for both our Jyothi students as well as for the external participants, the field of UG, PG as well as for the research guidance. Yeah, both any colleges can able to attend these internship programs. There is no restrictions for outside candidates. It will be open for everyone.
As of time constraints, we're winding up the sessions now. I hope there are no more questions by the participants. And thank you, sir, for that incredible, insightful session. We're winding up the session for today. As of tomorrow being the second day, we have a workshop organized on the topic Embedded Systems in PCB Fabrication, taken by Dr. Godwin Raj D. Hoping to see the same cooperation and enthusiasm tomorrow as well. So the team of IDC AGC takes this opportunity to thank each of you for showing valuable interest in spending time with us today. Special note of gratitude to our speaker, Professor Abubakar KM, for being with us today and for delivering an insightful session. Thank you, sir. Last but never the least, a heartfelt gratitude to each of the participants for showing keen interest and enthusiasm. And once again, thank you to all. And the feedback form is requested to be filled by the participants. Thank you.
Thank you.